Okay, let us try to solve this example problem for kinematics in one dimension. So a VW Beetle goes from 0 to 60.0 miles per hour with an acceleration of positive 2.35 meter per second squared. How much time does it take for the Beetle to reach this speed? And a top fuel dragster can go from 0 to 60 miles per hour in 0.6 seconds. Find the acceleration in meter per second squared of the dragster. So let us try to solve this problem. Let us first try to determine the givens, all the givens of this problem. So the given for the Beetle, it says it goes from 0 to 60 miles. Therefore, the initial velocity of the Beetle, its initial velocity is 0. Then its final velocity is 60 miles per hour with an acceleration of positive 2.35 meters per second squared. So this is just for the Beetle. For the dragster, a top fuel dragster, it's a race car. The given is the initial velocity of the dragster. It can also go from 0 to 60. So initial also is 0. The final also of the dragster is 60 miles per hour in just a time of 0.6 seconds. So these are the given for the Beetle and for the dragster. So what are the required? First, we are required to get the acceleration, the time for the Beetle to reach this speed. So we are being asked to find the time. Let t be the time for the Beetle to reach 60 miles per hour, and for the dragster, for the race car, we are asked to find the acceleration in meters per second squared. Dragster. This is in meters per second squared. So the given, these are the givens and the required. We are required to find the time for the Beetle to accelerate from 0 to 60 miles per hour. Let us go to the solution. Okay, let's try to solve. For part A, for the time it takes for the Beetle to accelerate from 0 to 60 miles per hour, first we need to convert its velocity. We should convert the velocity to meters per second, because the acceleration, if you'll notice, the given acceleration is, if you'll notice with the acceleration is in meters per second squared, but the given is in miles per hour. So we need to convert. Or we can just directly use it in our equation. Well, if we will have our conversion factor for miles per hour, 1 mile per hour, 1 mile per hour is approximately equal to 0.4470 meters per second. So let's use that conversion factor. Now let us go with our equation. So from our acceleration equation, according to our equation for acceleration is the change in velocity over change in time. So this is your delta V, change in velocity, change in time. Or we can have this as just the final velocity minus the initial velocity all over the elapsed time, or it is just delta t or the elapsed time, or just t. Now this time is the time it took for the Beetle to have a velocity of 60 miles per hour from 0 miles per hour. So if we are being asked to find the time, we'll just derive from this equation that t, or the time elapsed, is just equal to v final minus v initial all over the acceleration. Now let us solve for the time of the Beetle. Okay, the initial velocity, automatically this is 0, because according to the problem, from 0. So we will just have the final velocity, but we need first to convert the final velocity to meters per second. So we'll have v final 60 miles per hour, but according to our conversion, 1 mile per hour is 0.4470 meters per second. 1 mile per hour, initial velocity of course 0, all over the acceleration 2.35 meters per second squared. So miles per hour will be cancelled. So this will become 60 miles per hour times 0.4470 meters per second divided by 2.35 meters per second. So time is approximately 11.4 seconds. So it took 11.4 seconds for the Beetle to accelerate from 0 to 60 miles per hour. Now the second question is the acceleration of the Dragster. So this is a race car. So this is much faster than the Beetle. If you'll notice, for the Beetle, it took 11.4 seconds for the Beetle to accelerate 0 to 60. But according to our given for the race car, it will only took 0.6 seconds for the Dragster to reach 60 miles per hour. For the Beetle, 11.4 seconds. But for the race car, 0.6 seconds. Now, let us compute for the acceleration of the Dragster or the race car. Okay, let us solve for its acceleration. So acceleration is V final minus V initial all over the time, or delta t from our elapsed time. Okay, so the same. We'll have V initial is again 0. V final 60 miles per hour multiplied by our conversion factor 0.4470 meters per second all over 1 mile per hour all over 0.6 seconds. Okay, so the acceleration of the car, of the race car, okay, miles per hour, cancel. We will have approximately 44.7 meters per second squared. This is the acceleration of the race car or of the top fuel Dragster.